Hello, good morning. Good morning, everybody. Today, before we begin our continuation of our discussion, some housekeeping matter. I already finalized my schedule for the semester. My consultation hours are from 1 to 3 p.m. From Monday to Friday. Okay, so every week I'll be free from 1 to 3 p.m. to entertain your questions about the course. If you have questions about ACAD stuff, or you think I can give you some advice about your academic career as a student, so you can also drop by. Or kung wala naman nagtatanong ng ACADS or about Math 174, I can also be available for chit chat if you need somebody to talk to. Or kung gusto niyo lang magzumustahan or inuman. I mean inuman, coffee or juice. So you can drop by MS Teams from 1 to 3 p.m. I already added who is part of the Math 174 MS team to my online office team. Tapos ilalagay ko rin mamaya sa Canvas yung link para dun sa online consultations. I'll try to be in the meeting room from 1 to 3 p.m. from Monday to Friday. Pero kung nag-enter kayo ng meeting room tapos wala pa ako doon, just hit me up with an email or a quick chat, and then I'll be there shortly. Okay? So again, that's 1 to 3 p.m. from Monday to Friday. If you're not available during any of those times and you have some pressing issues, you can schedule custom hours or custom appointment hours. So just send me an email or send me a chat in MS Teams. Okay. So right. Okay. That out of the way. Happy Thursday, everyone. Malapit na mag-weekend. So meaning kailangan na nating matapos yung module number 3. But I don't think we can finish this for today. So I might ask your lab instructors to take over some of the topics here. And then accordingly, I'll need to adjust the deadline for laboratory exercise 1.2. So let's see what will happen. I'll let you know via Canvas and via Canvas later. So last time we talked about a strategy in minimizing the error in the interpolation. So alam na natin yung error term sa interpolation. It is comprised of two factors. One is dependent on the n+1 derivative of your function f and the number of points n, while the second factor is a polynomial omega, which is the product of x minus xabice. Now, our focus for this week is trying to minimize that error term by looking at the second factor. Gusto nating i-minimize yung omega. So we want to minimize omega of x by choosing the xabice wisely or optimally. But to further specify the criteria about minimizing omega, so i-minimize natin yung norm ni omega. And we have two types of norm, at least, that we consider in Math 174. The first one is the supremum or the L infinity norm, which is basically the L infinity norm of omega is basically just the supremum of the absolute value of f of x over the interval AB or the interpolatory interval AB. And then we have proven last time that in order to get the minimal L infinity norm, we want omega to be a Chebyshev polynomial. Kasi yung Chebyshev polynomials, sila yung nag-attain ng smallest L infinity norm among the monic polynomials of their degree over the interval -1 to 1. Okay? So para ma-achieve na yung omega maging equal sa Chebyshev polynomial, we want the roots of the Chebyshev polynomial to be the interpolatory abscissas. Again, this will only work if we have access to the function f itself. Kung alam natin yung gusto nating interpolate na function, so meron tayong degree of freedom para pumili ng mga interpolatory abscissas xabi. So kung pipiliin natin yung mga xabis to be the roots ng Chebyshev polynomial, we're guaranteed that omega, or the L infinity norm of omega, would be equal to 2 to the negative n, where omega would be degree n+1. Okay, so again, kung si omega ay product from kung si omega ay product, I going from 1 to n plus 1 ng x minus exabytes, and we choose the exabytes to be the roots of the Chebyshev polynomial to be the roots of t sub n plus 1. Kailangan ko yung degree n plus 1 na Chebyshev polynomial, right? Kasi itong omega ay degree n plus 1. So kaya, pag pinili ko yung exabytes to be the roots of t sub n plus 1, then the L infinity norm of omega is guaranteed to be minimal, and it is equal to 2 to the negative n. And this is where we stop right now. So ang where we stopped last meeting, yung L infinity norm ng t sub n plus 1 ay 2 to the negative n. Dahil pinili natin yung exabytes to be the roots of that monic Chebyshev polynomial or that Chebyshev polynomial, then the L infinity norm of the omega factor in the error term will be equal to 2 to the minus n. And we are guaranteed that this is the smallest possible L infinity norm. Okay. Now let's illustrate this process. We have, I think, 3 examples here in the module. So for instance, example 1. So ito yung example na meron tayong freedom to choose the exabytes kasi ang instruction dito sa 3.1, we want to find a degree 10 interpolating polynomial for this sort of complicated function, arctangent of x minus e to the x plus 0.5 plus x plus 2. Well, minsan ganito yung nangyayari sa application. Komplikado yung function f. So instead na halimbawa i-integrate si function f or i-differentiate si function f, or to perform some calculations on the functions f, on the function f, then we might want to replace it with a polynomial that behaves in a similar fashion as f. So gusto natin siyang gawing mas simple. In this particular case, we want to replace f by a polynomial of degree 10 that sort of mimics its behavior. Okay. Now, medyo mahirap na itong gawin ng mano-mano kasi malaki na yung 10 ay yung degree ng polynomial. So let's try using Matlab in order to answer this problem. Of course, yung answer nandito na sa module, but I want to share with you guys a solution or how I did it in Matlab. But again, you're not required to use Matlab. Ito lang yung choice ko na gamitin for the lecture to illustrate it. If you're using a different programming language, the pseudocode or the algorithm is the same. It's just that you need to translate the Matlab syntax into your chosen syntax. So there shouldn't be any problem with that. Gusto ko lang yung Matlab kasi again, you have free access to all the packages that Matlab offers. Hindi libre yung license Matlab, hindi rin siya mura. So luckily, the university provides us with a subscription to all that Matlab offers. So let's take advantage of it. Okay. So let me share my Matlab screen. Tigil ko lang tong sa iPad. Okay, share ko na yung buong screen. Hold on. Okay. Okay, hello guys. Can you hear me? Ito naghang yata yung internet ko. Pero I hope I'm still live. Disconnect na yung tablet ko. But guys, am I still live in the meeting?
Yes, sir.
Yes po, sir.
Yes po, sir.
Okay, thank you. So nawala lang yung Wi-Fi ko sa bahay. Good thing yung laptop ko ay nakakonect sa prepaid data. Okay, so let's go back to Matlab. So ang ginamit ko ditong base ay yung code ko from last time that I've shown you, yung interpolation, yung interpolatory nodes given a distinct set of exabytes. So kung mapapansin nyo, lines 28 hanggang sa dulo, ito yung pinakita kong code sa inyo. And then I'm just building on top of it, paano kung ang gusto kong gamitin ay Chebyshev nodes. So yeah, let's just take a quick look at it. So line 31, dito ko lang in-specify kung ano yung abscisses. Okay. Bigla nag-join yung iPad ko. Hindi siya naka-mute. Sorry about the echo. So line 31. Hold on. Bakit may echo pa rin? Ako pa rin ba yun? Okay. I hope this is better. Okay. Line 31, initialize ko lang yung abscisses. Line 33, I just inputted the given function values. Tapos remember the for loop in lines 37 to 47, which calculates the interpolatory polynomial. Hold on, guys. Talagang may echo. So, off ko na lang muna to. Okay, sa akin yata yung may echo. Okay, there we go. So, and then lines 49 until the end are just post-processing steps when you want to display in a pretty fashion ano yung interpolatory polynomial P, tapos mag-plot ng function P and so on. Okay? So, gusto kong gamitin tong code na to para i-define yung interpolatory polynomial of degree 10 using the Chebyshev nodes. Okay? So, ang pinagkaiba lang dito, yung mga exabytes na gagamitin ko ay yung roots ng Chebyshev polynomial. By the way, remember the problem is I want to find the interpolatory polynomial using the roots of the Chebyshev polynomial. So I need to find the roots of the Chebyshev polynomial first. So hold on, let me clear everything. Okay, there we go. So I can compute for the nodes, for the Chebyshev nodes in two ways, okay? Now, simulan ko sa long method. The long method, ang maganda sa kanya ay i-define din natin yung Chebyshev polynomials. We might need the Chebyshev polynomial later or for other applications. So why not compute it? Tapos yung short method, gagamitin ko lang yung remark 1.3.5 that we have seen last time. Pero let's see. I started my code with line 1, which is basically declaring that the variable x should be treated as a symbolic one. And then this next section would be computing the Chebyshev nodes. First, in line 6, I want to declare ano yung degree nung Chebyshev polynomial na gusto kong i-consider na hanapan ng roots. Remember, problem 1 tells us to find a degree 10 interpolating polynomial. So kung naghahanap ako ng degree 10 interpolating polynomial, I need at least 11 nodes, right? I need 11 nodes or 11 abscissas. So para magkaroon ako ng 11 abscissas, kailangan makuha ko yung 11 roots ng isang Chebyshev polynomial. So kailangan kong computein yung degree 11 Chebyshev polynomial. Okay? So that's why I have here 11. This is the desired degree of the Chebyshev polynomial. Para magkaroon ako ng 11 roots, 11 interpolatory nodes, so I'll get a polynomial of degree at most 10. And fingers crossed, sana hindi makancel yung x to the 10th na term para kung anong makuha ko ditong sagot, siya na yung answer dun sa exercise 1 or dun sa example 1. Okay. Now first, remember that the Chebyshev polynomials are defined recursively. So para makita ko siya as a polynomial. Of course, ngayon ko lang naisip, pwede ko palang gamitin yung cosine of n r cosine of x na definition niya. Pero for computers, mas okay yung polynomials kaysa dun sa trigonometric functions. Kasi yung trigonometric functions, sila ay transcendental. So ibig sabihin, computers need more work in order to deal with these transcendental functions. Mas madali para sa computers ang polynomials kasi ang involved lang sa polynomial evaluation are the 4 basic operations. So instead of using the theoretical definition of the Chebyshev polynomials, I will use the recursive formulas. Kasi I need to take into account na computers yung ginagamit ko sa pagko-compute. At hindi naman siya ganun kahirap. So, remember, dun sa recursion formula, kailangan ay gamitin ko yung previous Chebyshev polynomials to get the next Chebyshev polynomial. So, to keep track of all of these, I will store in an array T yung mga Chebyshev polynomials. So, dahil mga polynomials sila, they should be treated as symbolic variables. So here I initiated a vector T na dapat symbolic yung laman niya. So seems t, i-reserve lang ni Matlab na yung variable t will be a symbolic variable. Luckily, Matlab works for matrices and arrays in default. So ibig sabihin, itong t, unless specify ko yan later or gamitin ko siya sa scalar, tinitreat siya ni Matlab as a vector or as an array. So that means a t would be a symbolic vector. Okay. Now, initialize ko na yung laman. Remember, t0. T sub 0 is 1 and t sub 1 ay equal kay x. So ito yung unang dalawang Chebyshev polynomials. Now, the problem, we have a little bit of a problem here. Hindi naman malaking problem, pero madali lang naman siya. Nag-start yung indexing ni Matlab sa mga entries ng vector or matrices sa 1. So hindi ka pwedeng maglagay ng zeroth element or zeroth entry ng isang vector. So if I want to fill up t with the Chebyshev polynomials, I should start with the first entry, t of 1. So yung t of 1, siya dapat si t0. So ito yung t0 dun sa definition natin. So ang t0 natin ay 1. Tapos si t2 ay equal kay x. And this is fine because we declared x earlier as a symbolic variable. So ito yung t sub 1 dun sa lecture notes natin. So kailangan yung i-take note na parang nadagdagan yung index. So yung index dun sa matrix T ay 1 more than the degree of the Chebyshev polynomial. So yung T2, yung second entry dun sa vector natin of Chebyshev polynomials is actually the Chebyshev polynomial of degree 1. So may konting adjustment na nangyayari. Okay? And then I will now define the recursive step. Paano ko kukumputin yung mga susunod na Chebyshev polynomials? So they would be starting from the third entry of the vector t, meaning ito yung mga Chebyshev polynomials of degree 2 or higher. So I will create a for loop here that is in lines 12 to 14. Pero yung iteration start ko na sa 3 kasi alam ko na yung t1 at saka yung t of 2. So start ko na siya sa 3 hanggang matapos ako dun sa hanggang makuha ko yung degree 11 Chebyshev polynomial. Pero remember, nag-adjust yung indexing. So kailangan kong gawin yung iteration hanggang degree plus 1. Kasi yung t1 siya yung degree 0, yung t2 siya yung degree 1. Tapos yung T3 will be degree 2 and so on. So yung T11, siya lang ay magiging degree 10 Chebyshev polynomial. Pero gusto ko yung degree 11 Chebyshev polynomial. So kailangan dumiretso ako hanggang T of 13. By the way, guys, can you admit yung mga nasa lobby? Hindi lang makapag-shift ng window. Okay. Thank you. All right. So that's why ang iteration ko dito ay hanggang degree plus 1. So para makuha ko yung degree 11 Chebyshev polynomial. Okay. And then the ith Chebyshev polynomial in our list is computed as 2x times the previous Chebyshev polynomial minus the Chebyshev polynomial 2 steps back. All right. So tas i-end ko na yung loop. So in the end, I will have how many? I will have, in our case, I will have 12 Chebyshev polynomials, and they would be the Chebyshev polynomials of degree 0 until degree 11. Is everything good so far? Okay, I hope it is. And then, kailangan kunin yung roots ng degree 11 Chebyshev polynomial, or degree 11 Chebyshev polynomial. And dun sa ating list, yung degree 11 Chebyshev polynomial would be the degree plus 1 element. Right? Siya yung pinakadulo. Yung iteration, ginawa ko hanggang degree plus 1. So, kukunin ko ano yung pang degree plus 1 na entry dun sa symbolic vector t. Right? And then I will call it Tn. Tn is my desired Chebyshev polynomial. Okay? And then I will just ask Matlab to display ano yung simplified Chebyshev polynomial. Okay. Now let me run this part of the code. I'll run lines 1 to 17. One thing you can do is i-click nyo tong horizontal line sa tapat ng line 17. para magkaroon siya dyan ng breakpoint. I think Matlab will run everything until this line. Actually, hindi pala. Dapat yung susunod. So, ibig sabihin, magpo-pause siya before executing line 19. Okay. So, pwede ko na siyang i-run. Okay. And you see, ito na yung sagot. Okay. So, itong breakpoint na to, ito yung magsasabi kay Matlab, mag-pause ka muna bago mo i-run yung line na yan. Okay. And then there's an indicator that when I press continue here on the on the taskbar, ibig sabihin dito na siya mag-start mag-run ulit. Pero you see, we are successful in getting the Chebyshev polynomial of degree 11. Kasi may x na multiplier dito. This would be x to the 10th. So basically, the leading term is 1024 times x to the 11th, which makes sense kasi alam natin na yung leading coefficient ng degree n Chebyshev polynomial ay 2 to the n minus 1. So dito ang n natin ay 11. So ang leading coefficient niya ay 2 to the 10th, which is 1024. Okay. Pero hindi pa natatapos dun yung kailangan natin gawin. We want to find the roots of this Chebyshev polynomial. And remember, Matlab can compute the roots of a polynomial by using the roots command. Pero para magamit si roots command, kailangan ko munang i-harvest ano yung mga coefficients nitong Chebyshev polynomial na to. That's why I compute sim to poly of Tn. I-harvest niya lang yung yung coefficients ni Tn. So if I evaluate, if I continue here, okay. So na-compute niya na yung coef. Pag nag-hover kayo dito sa variable, tas may laman na siya, i-display ni Matlab yung values niya. So kung makikita niyo, ang first element nung coef vector ay 1024. That's the leading coefficient, followed by 0, followed by negative 2816. So ito yung mga coefficients niya. Okay. Now, since I know the coefficients, ito na yung proper input para dun sa roots command. So I can ask Matlab to compute the roots of the Chebyshev polynomial, and I will store them in the vector called Chebyshev roots. So bahala kayo magpangalan kung ano yung gusto niyong gawin. So yeah. So if I run this, continue running it. So I get now the roots of the Chebyshev polynomial. Again, if I want to pick at the value of these roots, pwede kong over dito. So yan yung mga roots ng Chebyshev. Okay. So is everything clear so far? Okay, I hope it is. So, alam na natin yung roots ng Chebyshev polynomial. But this took quite a number of lines kasi kinompute ko pa yung Chebyshev polynomial in a recursive way, tapos hinarvest ko yung coefficients and so on. May shortcut naman. We can take advantage of remark 3.1.5. So, I hope tama yung numbering ko. Silipin ko yung vortex. Yeah, 3.1. Statement 5. Dun sa statement 5, kinompute na or given na kung ano yung mga Chebyshev roots. So kung ayaw nyo nang computein yung mga Chebyshev polynomials, pwede nyo gamitin itong lines 22 to 25, which computes for the roots following the formula given in the remark. Okay? Mas madali ito from a computation point of view. Okay? Now you will get approximately the same answer with this long method. Kaya ako sinabing approximately kasi pwedeng merong mga rounding off errors kasi again, these are finite machines, ititigil nila yung computations at some point. So yeah, but you will get approximately the same results whether you use the long or the short method. Okay. Now, I will now use the interpolation code that we used last time, pero kailangan ko lang siyang i-modify ng konti. For instance, yung mga interpolatory abscissas, hindi na sila eto, kasi ang gagamitin na nga natin yung roots ng Chebyshev polynomial. So maybe I can change t to be the Chebyshev roots, to be the roots of the Chebyshev polynomial. Papalitan ko lang siya dyan. So pag nilagyan nyo ng percent, ibig sabihin lahat ng susunod sa percent ay comments na lang. I-ignore na sila ni Matlab. So yung t ay Chebyshev roots. Now, I need to compute the given function values. Pero paano ko kukomputein yung given function values? Well, one way to do this is compute it in a vectorized manner. So yung d, siya yung vector of function values. So ito yung given f dun sa problem. So kagandahan again kay Matlab, nag-work siya sa vectors. So halimbawa, gusto kong computein yung arctangent ng bawat Chebyshev root. So I just use atan. So ito yung code para sa, or syntax para sa arctangent of a vector t. So remember si t ay vector. Pag kinuha mo yung arctan of t, ibibigay niya ay vector na ang laman ay yung arctangent ng bawat isang value ni t or bawat isang entry ni t. So component-wise yung ginagawa niyang pag-compute ng arctangent. And then I will add it to e to the, ano ay sa problem? E to the x plus 0.5. Mga ba? Okay. Oh, sorry, minus e to the x plus 0.5. Ang e raised to something is exp of kung ano man yung exponent. So here our exponent are values of the interpolatory abscissas. So t plus 0.5 plus t plus 2. Okay. So ito yung vector of function values na. So let's see. Let me pause here. Continue. Okay. Bakit may error? Ano daw yung error? Ganap siya ng variable t. Hindi ko siya nalagyan ng breakpoint dito. Pero let's see. I-run ko lang tong d. Sorry. Hindi ko pa pala na-run yung t. Tama nga ba? Let's see. F9. Sorry. Equals pala yung nagamit ko. Dapat plus 2. Okay, there you go. So run ko to. Okay. So na-compute niya na yung d. At kung gusto niyo makita yung values ni d, pwedeng i-type niyo sa command window d, press enter. Ito yung mga function values at the given abscissas of which are the roots of the Chebyshev polynomial. Okay. So siya na yan. Tapos pwede ko na siyang idire-diretso hanggang dito sa dulo. Okay. Meron pala akong konting binago, yung variable ay ginawa kong x instead of t as what we used last time. Pero little change lang naman yun in the code. So I can now run the rest of the code before the post-processing step. And then no errors. So ito na yung na-compute na ni Matlab yung interpolating polynomial. And then let's just see here, line 50 to 52 para makita natin yung itsura niya. Ano pala nangyari kay P? Bakit si P ay naging, let's see, naging live debugging session, no? Bakit si P ay naging, kasi ang value daw ni P ay 0.3513. Bakit si P ay naging, single value na? Oh, I think I know what happened. Let me just restart here, clear CLC. Ang problema pala ay, remember dati yung t natin ay 1/5. Pero yung Chebyshev roots ay naging 11/1. Yan nga natin. So run ko ulit hanggang dito. Okay. So kung makita niyo yung Chebyshev roots ay 11/1. Isa siyang 11/1 vector. So it's a column vector. Pero dinesign ko yung AIP routine to work with a row vector, 1/5 dapat. So dapat maraming, isa lang row pero maraming columns. Pero yung Chebyshev roots ay na-store ko into an 11/1 vector. So to become consistent, kailangan kong kunin yung transpose ni Chebyshev roots. So para makuha yung transpose ng isang matrix, kailangan nyo ng dot apostrophe. So ito yung syntax para makuha yung component-wise transpose. I just need to be careful pag walang dot, pagka prime lang yung sinulat nyo or apostrophe lang, kukunin niya yung complex conjugate transpose. So you need to be careful kung gusto nyo ba yung transposition lang or gusto nyo kunin yung complex conjugate transpose. Pero dahil real number lang naman, well, okay lang na walang dot, pero it's a good practice to use dot apostrophe instead. So kunin niya yung transpose, so instead of putting having t to be an 11 by 1 vector, gagawin niya na lang 1 by 11. Tapos, let's see. Ganun din yung mangyayari kay D, magiging 1 by 11 na lang siya. And then I can run everything here until the post-processing step. Okay. Hindi ko pwedeng gawin yung substitution right now kasi t yung variable dapat ginawa kong x. Pero ito yung interpolatory polynomial natin. So hindi pa pala siya maganda yung inalabasan. Pero pwede ko siyang ipa-output in a better way. I'll VPA simplify the interpolating polynomial. Ito yung makukuha ko. Ito yung interpolatory polynomial of degree 10. Now, if you want to find it, to find the coefficients and compare it to the one in the notes, pwedeng gawin natin na maybe I can say, I can compute for the coefficient, sim to poly, no answer, which is the VPA symbol for P, or you just say sim to poly ni P. Kukompute niya yung coefficients. So you see you have something close to 0 as the coefficient of x to the 10th, and then followed by 0.02 or something close to 0.02 times x to the 9th, and then something close to 0 and so on. Gusto nyo makita yung eksakto mga value ng coefficients, you can click ANS in the workspace. So makita nyo itong mga values na to, ito yung eksaktong nandun sa vertex. Okay? Nandun sa module. So ganito natin na-derive yung interpolatory polynomial using the Chebyshev notes. Okay? Now, if you want to see yung plot ni P, so ito lines 55 to 56, F9. Yeah, medyo mabagal. Okay, there we go. Ito yung graph nung interpolating polynomial. Pero ang problema pala, dapat binabaan ko yung interval. Dapat from -1 to 1 lang. Kasi doon ang galing yung ating interpolatory nodes. Remember, our interpolatory nodes are the roots of the Chebyshev polynomial. So ang interpolatory interval natin ay -1 to 1. So if I run this again, yeah. Okay. Ito yung graph ng interpolating polynomial natin. Okay. Now, if you want to compare it with the graph of, say, the actual function, so pwede rin naman natin gawin. So pwede kong i-hold ito. Okay. Kung gusto nyo mag-overlap yung mga plots sa isang figure window, pwede kayo maglagay ng hold on. Pero huwag kayong maglalagay ng panibagong figure. So kasi yung figure siya yung nagsasabi na lahat ng susunod sa command na to ay nasa isang figure window lang. So figure and then hold on. Tapos gusto kong ipa-plot yung function na ini-interpolate natin. So fplot yung function na arctangent of x minus e to the minus e to the x plus 0.5 plus x plus 2. So gusto ko ring i-plot to from -1 to 1. Okay. So let's see. Press F9, evaluate selection. Okay, there we go. And you see na nag-overlap. Halos hindi natin makita yung difference between the two graphs. Tingnan natin kung pag nag-zoom in ako, makikita ko ba? Kahit mag-zoom in ako, hindi ko na nakikita yung difference between the two. Pero I knew that nag-overlap sila kasi different colors yung gagamitin ni Matlab para dun sa dalawang plots. The first plot would be blue. The second plot will be orange. Dahil halos magkadikit sila, so hindi natin visually makikita ano yung nangyari. Pero maybe it's better to look at the absolute difference between them. So pwedeng tingnan ko rin yung, or gumawa ko ng bagong figure. Tapos ipa-plot ko yung difference between them. So copy ko lang itong line 58. Kasi halimbawa gusto kong i-plot na yung absolute error. So absolute value ng P minus yung function F natin. Just be careful with the grouping symbols. Okay. And then, pwede ko siyang lagyan ng title. Title. Sa Matlab, kapag text yung gusto nyo gawin, lagyan nyo lang ng apostrophe. So, title, say, absolute error plot. And then, we can evaluate selection. Okay, there we go. So, ito yung absolute error. And you see that the maximum absolute error is actually around 1.4 times 10 to the negative 5. Yun na yung pinakamalaking error na na-incur natin. Okay? So, in this sense, magandang interpolation natin from negative 1 to 1. With the use of the Chebyshev polynomials, the roots of the Chebyshev polynomial, because the absolute error is just 10 to the negative 5. Okay. Now, let's see what happens outside the interpolatory interval. So, halimbawa, actually designed to for x's between negative 1 to 1. Ano yung mangyari? Halimbawa, lumampas tayo ng konti. Let's say, negative 5 to 5. I-compare natin ano yung behavior nung interpolating polynomial at saka nung function f over the interval negative 5 to 5. Palitan ko tong interval kung saan ko siya i-plot. Okay. And then I can right-click here, evaluate selection. Okay. Kung makikita nyo ay halos malayong-malayo na yung behavior nila. Kasi yung interpolating polynomial natin, yung kulay blue, siya ay it attains a maximum of 3 times 10 to the 4th over the interval negative 5 to 5. Pero yung function natin ay halos hindi natin makita yung behavior niya kasi halos nag-flatline lang siya from negative 5 to 4 kasi I need to be hindi ko na pala talaga makikita kasi masyadong maliit yung values niya. Okay. So makita nyo, hindi na guarantee yung pagiging accurate nung interpolation dun sa labas ng interpolatory interval. So guaranteed lang yung error bound for all x's between negative 1 to 1. Pero outside of the interval negative 1 to 1, we don't know what will happen to the error. Kasi yung error term natin valid lang siya for x's between the smallest interpolatory abscissa and the largest interpolatory abscissa. And outside of that, we don't know what will happen. Pero try ko nga negative 1.5 until 1.5. Para at least makita pa natin yung behavior niya. Yeah, 9. Okay. So from negative 1.5 to 1.5, medyo okay pa siya. Medyo nakita nga lang natin na medyo nag-start na siya mag-deviate dito. At saka dun sa tail end after 1. Pero palakihin pa natin, say negative 2 to 2. So ito yung graph niya from negative 2 to 2. So makita nyo, ang interpolating polynomial natin yung blue, yung actual function ay yung orange. So yeah, makikita nyo na yung difference silang dalawa. But again, over the interval negative 1 to 1, maliit lang yung error. Okay. Kasi yun lang naman talaga yung pinramis sa atin ng interpolating polynomial. We will get nice results for x's between the smallest and the largest function value. Oh, sorry. Largest interpolatory abscissa. Okay. Any questions? Is this making sense? Nag-make sense ba yung code?
Pero personally, hindi ko po masyadong gets yung syntax ng Matlab kaya I can't really ask anything about it.
Okay, yeah. Pero at least does the process make sense? Kasi kahit ano naman yung gamitin yung programming language, ganito rin yung magiging takbo nung program nyo. So the important thing is you get the idea at bakit ko kino-compute yung bawat isang line. So you don't need to use Matlab, pero if you want, ito yung silver lining if you want to use Matlab, take advantage of the silver lining nitong online classes. You can go back to the recording at tingnan yung syntax na mga ginamit ko. So just make sure you understand what each of the lines stands for, kung ano yung pinapagawa niya kay Matlab. Okay. Pero you can implement it in Python, you can implement it in Scilab. Scilab dati yung ginagamit ko, which is the free version ni Matlab. Ano pa ba? You can also use Mathematica. So wala yatang subscription ng UP sa Mathematica and so on. But any questions about the concepts or concept-wise? Let me see. Ano yung susunod na example? I'm trying to have my other device connected. Para makabalik tayo dun sa Vortex. Hold on. Okay. I think now I can join the meeting. There we go. Okay. So that's one way of how to get the interpolatory polynomial using Matlab. So ito yung makukuha nyo, T sub 11, ito yung Chebyshev polynomial, ito yung monic version niya, tapos ito yung interpolating polynomial na nakuha natin using Matlab. Okay. Now, we can also find the error bound or find the theoretical error bound in interpolation. So sa example 3.2, yun yung ginawa niya. So you can try on your own and try to recover this interpolatory polynomial for e to the negative x over the interval -1 to 1. Okay. Pero yeah, hindi ko na siya ira-run dun sa Matlab. Kasi ang kailangan ko lang naman dito ay I want to emphasize how to get the error bound for this polynomial, error bound for this approximation. Okay. So remember yung error, ano nga yung formula sa error bound? Yung absolute error would be less than or equal to the n+1 derivative of f evaluated at some number psi all over, actually equal to dapat n+1 factorial times omega of x. Pero pwede natin itong palitan nito. This will be less than or equal to sa maximum ng absolute value ng n+1 derivative ni f evaluated at psi all over n+1 factorial. Or hindi na siya psi kasi maximum nga yung kukunin ko. So maximum ng n+1 derivative ni f evaluate at x's from -1 to 1. Kunin ko yung maximum absolute value ng n+1 derivative over the interval -1 to 1 divided by n+1 factorial times the L infinity norm ni omega. Okay, so ito yung error bound natin. Okay. Pero alam na natin dahil ginamit nating nodes dun sa interpolation ay yung roots ng Chebyshev polynomial. So ibig sabihin, alam ko na itong L infinity norm na to. Itong L infinity norm na to ay magiging 2 to the -n, right? Pero n is the degree of the interpolating polynomial, so this is degree 10. So magiging 2 to the -10 yan. Okay. And then this would be 11 factorial. Okay. That's n+1 factorial. And then kunin natin yung n+1 derivative ni f. Si f ay, ano nga si f? Si f ay e to the negative x. So ang kanyang derivative ay what? Ang derivative niya ay sarili niya. Pero nagkakaroon ka lang ng alternating powers, right? The first derivative is negative e to the minus x. Second derivative would be positive e to the negative x. Third derivative would be negative e to the minus x. So basically, siya ay negative 1 to the n, right? So ito yung kanyang nth derivative. So ang n+1 derivative niya ay ito. Or actually, yung n+1 derivative naman ay nandoon sa loob ng absolute value. So ibig sabihin, hindi na nagmamatter itong alternating sign kasi kukunin ko naman yung absolute value. So kunin ko lang to. E to the negative x. Alright? Or pwede itong isulat na nasa denominator. 1 over e to the x. Okay. Hold on. Parang may problema dun sa solution. Bakit meron akong e dito sa taas, sa numerator? Pero yung function ko ay e to the minus x. Kung siya ay e to the minus x,
Sir, maximized po siya at x equals -1. So, e na lang po siya.
Okay. Yeah, thank you. Yeah, thank you. Good catch there. So talagang meron kang e to the x sa baba, pero gusto nating i-maximize itong fraction na to. Pero e to the negative x is decreasing. Decreasing yung e to the minus x. So ibig sabihin, ang maximum value niya ay nandun sa pinakamaliit na value ni x, which is -1. So this maximum ay magiging nasa e to the -1. Okay. I think I lost my connection. So yeah, I'm back. So meron kang e to the -1 dun sa ilalim. So it will become e dun sa taas. So I will have e over 11 factorial times 2 to the -10. And this would be your error bound. So hopefully that is equal to this guy. Okay, so kindly double check with your calculators. Pero yun yung error bound. And again, pagkuha ng error bound, gusto natin ano yung maximum possible error. Okay, maximum possible absolute error. Alam natin eksakto siyang ito. Pero we can compute for the maximum value of the first factor para makakuha tayo ng upper bound. Tapos yung omega, alam natin eksakto to the -10 yung maximum value niya. So basically, we know that the error will not exceed 6.65 times 10 to the -11, which is pretty good. Kasi napakaliit na ng 10 to the -11 as an error. So it is almost machine precision. Usually, calculators have 16 degrees, 16 decimal digits retained after most of their calculations. So kaya almost nasa machine precision na tayo. Na-preserve niya yung 11 decimal digits no ating desired numbers. So I'll say, yeah, we can conclude that this approximation is very good. Kasi napakababa nung absolute error in the worst case. So alam natin, hindi na lalampas dito yung error. So I think we're good with 11 decimal digits. Okay. Now let's see. Okay, maybe I'll borrow 5 more minutes from you guys para lang matapos natin yung Chebyshev polynomials. And then we will decide later if you will discuss the Legendre polynomials in the laboratory sessions or wag na lang muna. Tapos ang magiging due na lang na part ng lab exer 1.1 ay yung about sa Chebyshev. Okay, so I will announce it in Canvas later. Antayin ko lang matapos yung lecture ko tomorrow dun sa kabilang section, but we'll decide soon and we'll let you know. I want to devote the last 5 minutes or the additional 5 minutes paano natin magagamit yung Chebyshev roots kapag yung function to be, we want the interpolatory interval to be beyond -1 to 1. Kasi sabi natin yung Chebyshev roots ay between -1 to 1 lamang. So yung interpolation is valid only for x's between -1 to 1. Kasi outside of that interval, we cannot guarantee what happens to the error. We don't know what the error value is. Or yeah, we also don't know what an error bound would be for x's outside the interpolatory interval. So para magamit natin yung Chebyshev nodes, kailangan lang natin silang i-scale at i-translate into a desired interval. And I guess hindi na naman nag-screen share. Let me try again. Ubus na yung inutang kong 5 minutes sa inyo. Hold on.
Guys, nawala ba si sir?
Wait lang daw, sabi ni sir.
Okay, hello everyone. Sorry about that. I got disconnected. Narinig niyo na ba uli ako? Sorry about that. Yeah.
Yes po, sir.
Yeah, ubus na yung 5 minutes na inutang ko sa inyo. So, yeah, let's just continue this on Tuesday. So, ibig sabihin hold on. Ano kaya maganda? Siguro sa lab, ipa-illustrate ko na lang sa lab instructors niyo kung ano yung gagawin kapag yung interpolatory interval ay hindi na -1 to 1. Okay? Kasi yun yung drawback nung paggamit ng roots ng Chebyshev polynomial. Kasi again, yung roots ng Chebyshev polynomial ay between -1 to 1 lamang. So at most, the interpolation is guaranteed to be good or is guaranteed to be bounded by the error term or by the maximum value of the error term kapag yung excess na pina-plug in natin dun sa interpolating polynomial ay between -1 to 1. Pero pag nasa labas ka na nung interval -1 to 1, wala na tayong control kung ano mangyayari dun sa error. Kaya nga ang tawag sa kanya interpolation. Nandun ka dapat sa loob nung interpolatory interval. So kapag yung x, kung saan mo gustong i-approximate yung function, is outside of the interpolatory interval, wala tayong control dun sa error. So in example 3 in the module, we want to approximate the same function as we implemented on Matlab, pero from -5 to 3 yata or -3 to 5. So nasa labas na siya nung -1 to 1. Pero we can scale and translate the Chebyshev roots para mag-span sila from -5 to 3. And I think that's one thing that I want your lab instructors to discuss with you on Monday. So paano tinatranslate yung roots ng Chebyshev polynomial para mapalawak yung interpolatory interval para sure tayo na yung approximation will be good over that larger interval. So any interval beside -1 to 1. Okay? And then tuloy natin sa Tuesday yung Legendre polynomials. So eto na. So yung magiging due on Monday would be yung part ng exer about Chebyshev polynomials. And then yung Legendre polynomials, siguro gawin na lang natin sometime late next week or even Monday next week. Monday week after next. Okay? So I hope that is okay with you guys. Medyo delayed nga lang tayo dun sa study guide. But yeah, it's better to be delayed that way kasi madaliin natin yung discussion sa mga topics. Okay, any questions? Again, I apologize for the inconvenience. Yes, CK?
Dun po sa equally spaced abscissas over the interval -1, 1, arbitrary po ba dun yung pagkuha ng abscissas? Basta po equally spaced?
Yes. Pero sana gawin niyo siyang equally spaced starting from the boundary of your interval. So kung sinabi ay kuha ka ng equally spaced points from -1 to 1. So kunin yung unang test point si -1, unang abscissa si -1, tapos last abscissa si 1. So yung step size nyo, pwede nyo computein b minus a all over n or all over n plus 1. So alin man dun sa dalawa. Kung alam nyo na yung n yung number of points, n yung gusto nyo number of equally spaced points.
Siguro po sir,
does that make sense?
Ano po sir, siguro po wag lang ma-touch na abscissa yung kung saan yung mama-maximize na value ni x kasi mag-zero po siya sir, di ba?
Okay, yeah, dapat hindi matatouch si 0. Or yung anything na magpapa-undefined dun sa function f. Yep.
Salamat po
Pero
sir.
if there are some problems with that or examples like that na magkakause ng problem, so just let us know kasi magrereklamo yung program nyo na mag-divide by 0 or something not in the domain.
I mean sir, yung error magiging yung omega of x sir, magiging 0 po yun sir kung matouch kasi sir yung yung x na
Okay, sorry. Okay, sorry CK, medyo choppy yung audio. Pero yeah, magzi-zero yung error, yun ba yung gusto mo sabihin? Yung error dun sa error bound ba yun?
Opo sir, opo.
Kasi kapag kumuha ka ng error bound, so kukunin mo yung maximum sa lahat ng x dun sa given interval. So, ibig sabihin, it doesn't matter if it's one of the equally spaced points that you use kasi definitely, pag ang pinang-substitute mo dun sa error bound ay isa dun sa mga interpolatory abscissas, yung error talaga magiging equal kay 0. Kasi alam natin na 0 yung error dun sa mga interpolatory abscissas. So hindi siya yung pwedeng mag-maximize ng absolute value. So kaya yung candidate nyo para dun sa error bound, dun sa x value na isa-substitute nyo dun sa error bound ay hindi isa dun sa mga interpolatory abscissas. Yeah, I hope nakuha ko yung gist ng question mo, CK. Medyo choppy kasi yung audio kaya hindi ko alam kung on the same parehas yung pinag-uusapan natin. Pero yeah. Okay, any other questions? Perhaps it might be better if you put it in the chat. Bigla naputol yung mobile data ko. Hindi ko alam kung bakit. Tapos sumabay din yung wifi namin. But yeah, any other questions? Okay, if none, then I think that's it for today. Thank you guys for coming. And again, I apologize for the inconvenience, technical issues, internet connectivity. But I think we all have experienced that in one form or another. So enjoy your weekend. Last meeting na natin for the week. Let's see each other again. Okay, bye guys.
Thank you po sir. Bye po sir.
Thank you po, sir.
Thank you, sir.